This is Manufacturing Systems Design Lab 2 in, ladder logic diagrams. So in this lab, we'll be programming this manufacturing production system using the ladder logic language, right? So before we get started, I want us to go here, and then we're gonna look at the state of a normally closed contact or switch works. So a normally closed contact or switch works in this proper way. It's always closed, right? But when it is pressed or activated, it opens up, right? This is the same principle of how your stop button works, for example. So your stop button, it's always closed, and then at a point where you press it, it opens up. That's why when you press your stop button or off button, everything turns off, because like you are cutting the power to your circuit, right? And then a normally open switch or contact, it's always open like this. But when you press it, it's like you are closing it, which enables current to go through, right? So like keep in mind with these like states, normally closed and normally open, because they are very important in us programming our manufacturing system. So with there are also normally closed sensors and switches. For example, here on our manufacturing system, here. So as you can see, this switch here, it's off, but when a part moves, so as I was saying, if you look at this sensor here, right, it's currently off, but when the cylinder extends or ejects the part onto the conveyor belt, then to here, it turns on. So that's the concept of how a normally open switch or contact works. It's always off, like an open circuit, and then when it detects a part, and then it closes down, and then resulting in a closed circuit. But if you look at this sensor here, right, it's always on, but but at a point where it detects a part, it turns off. So that's how a normally closed sensor switch or contact works. It's always on, which means closed circuit, but when it detects a part, it opens up, resulting in an open circuit, right? So now we're gonna start on programming our machine, right? So we're gonna go to Codesys, and then we're gonna say initially what we want to do. We want to press the start button, and then we want the machine to eject a part onto the conveyor belt, right? So now we're gonna go back here, and then we're gonna look for a start button, which is P1, right? P0, sorry, it's P0. So we're gonna say here for contact, this is for an input, right? So we're gonna say when P0 is pressed, want our cylinder to extend. So we're gonna look for our cylinder. You can go back and refer here. So our cylinder is indicated in this picture, it's Q4. So when I say when you press P0, want our Q4 to be actuated, right? And then we're gonna go to login and then play. So now I want you to look at the state of our sensors. As you can see, P1 is currently true, which means it's always on, as in a normally closed, as in it's a normally closed it's a normally closed contact. And then even our I2, this sensor here, it's always on. Like this can help us like indicate or understand like sensors that are normally closed or normally open, whilst the other sensors that are currently false, they are normally open. They only get activated when they are pressed or when they detect a part. So now when I go back to after we run our code, we want to go back to CIROS, and then we want to press. We said if we press the start button, we want the cylinder to extend. So now if we press the start button, as you can see, the cylinder is extending, but it's not extending to its end position. This is because the cylinder, it's not latched. And then latching, it's like a way for us to press the start button once, and then a continuous signal is sent to it's sent to the Q4 or a cylinder, so that it extends fully enough without us having to press and hold the start button. So how we latch our circuit is we latch it by connecting the output in parallel with the inputs. So we're gonna come back here, and then we're gonna say Q4, and then we're gonna also put our stop button here. Putting our stop button here enables us to be able to cut the power going to the output at any point in the process, but it won't affect the functioning of the circuit since it's always closed, which means current will pass through to Q4 unless at a point we want to stop the flow of current. So that's when we can press it, and then it will turn off. So now we run our code, and we always have to log in with download, right? And then now, as you can see, I only press the start button, right? So now, as you can see, I only press the start button once, and then the cylinder fully extend, right? But now, since the cylinder has fully extended, right, we want it to go back to its original resting position before the conveyor moves. So as you can see, the cylinder has this other side that's gonna interfere with our movement of the part to the end part of the conveyor. So we need to to ensure that it goes back to its resting position before the part begins to move. So now, let's say we want. So now we want to look at the sensors connected to the cylinder, right? So as you can see here, there is this sensor I4, this is sensor I5. Sensor I4, which is labeled here, sensor I4 and sensor I5. So sensor I4, it's always on when it's always on since the cylinder's resting position is at the back end position, and then cylinder I5, cylinder advance, it only gets activated when the cylinder is at the front end position. Like now, as you can see, it's on, but this one is off. So now we can try and use our sensor I5 to make sure that it goes back to its original resting position before the conveyor begins to move. So now we're gonna say to take I5, right? And then we're gonna try and use it to stop our Q4 when it's fully advanced. So we're gonna say I5 here, I5, right? But now the problem with this is that when the cylinder is at the back end position, like now, as you can see, our I5 becomes off. So now if you put I5 like this, current will not go through to Q4 due to the fact that our state of I5, when the cylinder is at the rest position, the state of I5 is going to be normally open. So now if, like, as you can see, like from basic understanding of circuits, this entire parallel connection is in series with P1 and I5, and then P1, since P1 is always on, current will flow through it, and then even in P0 current will flow, but when it gets to I5, since I5 is a normally open contact, when the cylinder is at the rest position, current will not flow through. So now we have to do what we call a negation. Or so a negation, how a negation basically works is that it will make the center I5 on when the cylinder is at the rest position, and then when the cylinder is fully advanced, this sensor will turn off, and then resulting in the cylinder going back. So in this one, what we're basically doing here is that we're converting the state of I5 from being a normally open into a normally closed contact. So now how we do that is we do what we call a negation. So we negate it. So now if we have put our I5 like this, our I5 is going to become a normally closed sensor, right? So current will flow through here, here, and here, and then it will reach Q4. So now we run our code, and you always have to log in with download, as I've mentioned before. So now we go back to our machine, and then we remove this part here, right? And then as you can see now, when our cylinder reaches the front end position, it immediately retracts, right? And then now we can look at what has been activated, for example. So as you have seen now, right, or as I explained in the beginning of the video, this sensor, it's normally open. As you can see, when the pad was moving from the cylinder to this conveyor, this sensor got activated. So we can try and use this sensor to activate the conveyor belt. So this sensor here, it's labeled as I1 or point B, right? So when I go back to here, right, and then we're gonna, as you can see even here, it's labeled as point B or I1. So we're gonna insert a new network, and then we're gonna say I1 wanted to activate. So now we're gonna say point I1 or point B, this sensor here, since it became activated when the part came to this point. When I say I1 wanted to activate our conveyor belt, so our conveyor belt in this regard, it's labeled as Q0, right? So when I say when sensor I1 is activated, we want our Q0, Q0 to be activated. And then for us to ensure that the I1 sends a continuous signal to Q0, so Q0 can keep moving. Because if for instance, let's say the pad comes to here, right, and then the pad will begin moving immediately after the sensor turns off. If you didn't latch this sensor, the conveyor will stop because the signal won't be there anymore. So now we have to latch our circuit here, which you wanna latch it by the output, and then you wanna put in our P1 in case we need to stop the process. So now we're gonna run our circuit again. So now I insert a pad, and then sensor detects it, and then moves to the end part of your conveyor. But as you can see now how this circuit is working, the parts are falling off. So if you want to ensure that the parts, when the parts reach the end part of the conveyor, they stop, you can use this sensor to stop the parts. So now if we look at the state of this sensor, it's normally it's normally closed. And then when the parts move and then they move past this sensor turns off, right? So I can use this sensor to stop the conveyor belt in this regard. So now I'm gonna come back here and look at the name of the sensor at the end part, which is I2 or point C. Then when I come back here, then we're gonna say I2, right? And then we're not gonna negate our I2 since it's in its original state. It's always true, or it's normally closed, which means current will be always passing through it. And then at a point where the part reaches this sensor will turn off, right? And then if this sensor turns off, since I explained this entire thing, this and this and this, they are connected in series. So if one of them doesn't work, the entire circuit will not work. So now, if this is always on, this is always on, and then let's say this is on, right? At a point where the conveyor reaches the end of the conveyor belt, I2 will turn off when it detects a path, right? And then resulting in it cutting power going to Q0. So now our path should stop when it reaches the end of the conveyor, right? So now, if you experience a problem like this, I want you to do this, right? I want you to go to edit mode initially, and then you move the part towards the end of this sensor, and then you throw it out, and then now our code should work. So now you press, it actuates, and then it stops towards the end, as you can see. Now this is due to the fact that now power is not going to I2, since I2 gets turned off when it detects a part, right? So now with regards to the cylinder ejecting a part, as you can see, the movement it's almost too instantaneous, and it results in this end part of the in this other side of the cylinder interfering with the part in the roller. So what we want to do is that we want to delay input I1 by a certain amount of time before we let it actuate, to enable to give the cylinder enough time to go back before the conveyor moves, so there's no interference between the two outputs. So we want to accomplish that task by using a timer to delay the the activation of I1. So what's going to happen now is that a part will come to this point, and then since I1 will get activated. But since you want to add a timer, the timer is going to delay its activation. So instead of it being activated immediately when it detects a part, it will wait for 2 seconds before it gets activated, giving enough time for the cylinder to go back, and then it will begin to move. So how we put in a timer, we come back here again and insert network below, right? And then since we want to delay the want to delay the we want to delay the activation of I1, we're going to use I1 here, and then we're going to go back to the side to function block diagrams, and then we're going to drag this this function block. It's called a relay, right? So now you're going to get something like this when you drag it, and then you're going to press OK. And then this function block will give our timer the ability to latch. So we don't have to latch our timer using this method. We latch it using the relay, right? And then we're gonna now take our timer. This is our timer, for instance. So now this is gonna be our timer. It's this function block, right? And then we're gonna declare its variable, right? And then we're gonna come back to, we're gonna go to ET, and then we're gonna cancel out these question marks, right? and then here this is where we'll be inputting our time. So how we input our time, we're gonna say t hashtag, and then let's say want to delay our want to delay the activation of input I1 by 2 seconds, for instance. So when I say 2 seconds, and then since we want to delay I1, we're gonna say I1 here, and then we're gonna put in our output. So in our output, we're gonna use a memory, right? Which we're gonna call M0, and then we're gonna declare the variable. So a memory ledge, it's like we're creating another variable for I1, but now our I1 will have the delay of 2 seconds, and then the memory ledge will be an input of I1 plus the time, which means our memory ledge, it's like we're saying I1 will become activated after 2 seconds. So now we have to always have a way to reset our time. So how we reset it is that we're gonna reset it by P1, right? But now if if we if we put it in like this, right? Since since our P1 is always on, our timer will be always resetting, right? So we have to change. Since our P1 and stop button, it's always on. Our timer will always be resetting, right? So now we have to change the state of P1 into a normally open, and then when we press it, it closes down, and then reset our timer. So how we do that is that we negate it, right? So now our timer can become resetted by P1, but with our timer being resetted by P1, we don't always want to press the stop button every time we want to reset our time. We want it to reset automatically. So we're also gonna use this sensor here towards the end to reset our time, right? And then we're gonna come back here, and then we're gonna insert parallel below, right? Like this. And then we're gonna say our sensor here towards the end is sensor I2, right? So we're gonna say I2. So when I use I2 to also reset our timer. So as you can see, since this is connected in parallel, this is an also either this or this can reset our time. But then we have another problem here. Since our I2 is always on, it's also gonna always be continuously resetting our timer. So we have to change the state into a normally open. Then so that when the path reaches the end part of the conveyor belt, it turns on, then it turns off, then the timer automatically resets. So how we're gonna do that is that we wanna also negate our I2, right? And then now with our I2 negated, our timer should only reset when the path reaches the end part of the conveyor. So now, since we want our conveyor to move after 2 seconds, and then we've created this memory ledge, which is an input of I1 plus a delay of 2 seconds. So now we're gonna come here to replace our I1 with M0. So M M0, as I said, it's an input of the timer plus I1. So now when our path reaches I1, so this sensor will take 2 seconds to turn on, whilst the cylinder is going back to its original back end position, right? And then after 2 seconds, the sensor will become activated, and then the path will move to the end of the conveyor belt. So now we are so now like when we adding a timer, as you can see, even here, since we declared it, it should appear here, right? And then we should go back to, since we added a timer again, we should go back to our symbol configuration, and then we build. And then after we build, make sure that all of the symbols or variables are selected, and then you build again, right? Then you come back here, and then you log in with download, and then now since we have added all of our all of our variables, and then we've also added the timer before. As you can see, like you'll observe now, when the part comes here, it will not move almost immediately when the sensor gets turned on. It will count for 2 seconds, and then it will move to the end part of the conveyor belt. So now, if I press my start button, so now, as I said before, if you experience this problem and you know that your code is in the correct state, you just select your part and then you move it towards this sensor here, and then you throw it out, and then now your machine should work. So now when you press I1, as you can see, it's gonna wait for 2 seconds and then it moves towards the end, right? So now from even this context of from even the context of Codesys, I want to show you the timer counting down. As you can see, now it's counting up after 2 seconds. Then the memory latch becomes activated. Then the memory latch, it's used to activate Q0, which is our conveyor belt. Then it will move, right? So now this is how you program using structured text for manufacturing system design practice lab 1, right? So yeah.